Welcome everyone to my channel, and today we have a polynomial equation which is of fourth degree, and the question reads x to the power of 4 minus 4 equal to 0. What there will be the possible values of x? Here we are expected to get 4 roots of x, including the imaginary roots. In other words, we have to solve for both the real roots and the imaginary root to this equation. But before we go into today's challenge, if you are new here, kindly subscribe and turn on the bell notification button so that you get notified whenever we drop a wonderful video. Also, video like the one you're about to watch right now. Now sit back as we dive into today's challenge. So we take our selection. So have here selection. Good. Now from here, let's put down our question. The question says x to the power of 4 minus 4 equal to 0. Now, our 4 can also be written as 2 to the power of 2. And so our equation becomes x to the power of 4 minus 2 all to the power of 2 equal to 0. Good. Now, from here, look at the exponent here. Here we can rewrite this as 2 times 2. And so this will now give us x to the power of 2 multiplied by 2, okay, minus our 2 to the power of 2 or equal to 0. Recall the law of indices, which says that if we have our a to the power of mn, this could also be written as a to the n bracket m, or your a to the power of m bracket n. It has changed the position of the exponent. Okay, so if we succumb to this, we can now have our expression here as our x to the power of 2 bracket 2 minus 2 to the power of 2 equal to 0. Very easy. Okay, let's proceed again. If you look at this carefully, you will see a difference of 2 square played out already. And what does it say? The difference of 2 square says that if you have your x to the power of 2 minus y to the power of 2, this is equal to bracket x plus y close bracket x minus y close bracket. And so if we succumb to this rule, which is the difference of 2 square, then we cannot consider our x to the power of 2 as x and 2 here as y. So if we go ahead to apply that rule, we're going to have something of this kind. We're going to have here to be our x to the power of 2 close bracket or to the power of 2 minus 2 to the power of 2 will give us the bracket x squared plus 2 close bracket x squared minus 2. Everything equal to 0. Good. Let's forge ahead. Now we take this. So this now implies that bracket x to the power of 2 plus 2 close bracket x to the power of 2 minus 2 close bracket equal to 0. Now we succumb to the zero product rule, which says that we equate this to 0, equate this to 0. So we're going to have this to be x to the power of 2 minus 2 equal to 0, or your x to the power of 2 minus 2, sorry, this plus 2, they're equal to 0. Easy. Here we have two cases to solve for. So the first case is this, second case is this. So let's take the first case. So we have case 1. Case 1 says x to the power of 2 plus 2 equal to 0. Now, of course, this is a quadratic equation. So we have to solve this quadratically. Okay, so this is a constant. So let's move into this side of the equation. So we have here x to the power of 2 equal to minus 2. Because where plus causes the sign of equality, it turns to minus. What we do here is to take the square root of both sides. So this will give us x squared, the square root equal to the square root of minus 2. And so we introduce plus minus here, 2. Okay, this sign will go with this 2 here. And so we have here x will now be equal to plus minus the square root of minus 2. Okay, yeah, according to Sword, we can rewrite this as our x equal to a plus minus bracket square root of minus 1 then times the square root of 2. This will give us this back. And so we recall the identity which says that the square root of minus 1 equal to your I. So if we succumb to this rule, then this will give us 1. And what is the value, or what is I? I is imaginary number. And so we can replace I here. So this will now give us x, therefore is equal to plus minus the square root of 2I. Very easy. Okay, we go again. Now we have 2 roots from here now. Okay, so let's keep this as our first 2 roots. We go to case 2. So we have case 2, case 2. Let's break down our question from case 2. This is our question in case 2. So we have this to be our x to the power of 2 minus 2 equal to 0. Collecting items, we have x squared equal to 2. Again, take the square root of both sides, take the square root of both sides, and produce your plus minus here. So this we go with this. We now have x equal to plus minus the square root of 2. Okay, so this is the answer to the second quadratic equation. So we now have our 4 roots. So the 4 roots to our expression here now could now be, we can go ahead to write out x1. x1 is equal to, let's take the real root first. We have plus root 2, comma, the x2 is equals to minus root 2. Then again, our x3 is equal to plus root 2I, and our x4 is equal to minus root 2I. Okay, it's our I place. All right, now let's check if our answers are correct. The roots to these questions are correct. So I'm going to take the first positive root and the negative imaginary number. So we're going to check with this if our answers are correct. Okay, let's check. We said we're taking the first real root to check our equation. So let's check when x is equal to your plus root 2. So we bring down our equation, which is x to the power of 4 minus 4 equal to 0. So wherever we see x, we'll put in plus root 2. And so this implies that your root 2, which is plus r to the power of 4 minus 4 equal to 0. We said our 4 could also be written as 2 times 2. And so if we write that, we're going to have here bracket root 2 close bracket r to the power of your 2 times 2 minus 4 equal to 0. Okay, now I can rewrite this, what I have here, as your square root of 2 bracket 2 or into our square bracket 2 minus 4 equal to 0. This will go with this. So I'm left with 2 in here. So I'm going to have here 2 into this 2 we have up here minus 4 equal to 0. And 2 raised to power 2 will give us 4. So we're going to have here 4 minus 4 equal to 0. So 4 minus 4 will give us 0. This equal to 0. So it shows that the first real positive root is correct. But let's take one of the imaginary roots, which is the negative one. Okay, so let's check when x is equal to minus root 2i. So whenever we see x in our equation again, let's put this value here to see if it will give us the correct answer, if it will satisfy our equation. Okay, so we proceed. We're going to have here our equation s to the power of 4 minus 4 equal to 0. So let's put in this value in there. So we have here minus root 2i all to the power of 4 equal to 0. Sorry, minus 4, yeah, sorry. Minus 4 equal to 0. Again, we can rewrite the exponent as our minus root 2i or into 2 multiplied by 2, then minus 4 equal to 0. So this gives us minus root 2i bracket into 2 or into a square bracket 2 minus 4 equal to 0. Good. Now look at the manipulation here now. Very easy. If you look at this, your I here, we said I is same thing as your square root of minus 1 is equal to our I. And so we can equally bring out that here. Okay, so if we do that, we're going to have this to be minus root 2 there times, okay, so let's put it times root minus 1 or into 2. Everything into our square bracket again, 2 minus 4 equal to 0. Very easy. Now, if we use this inner power to open up everything we have here, it means, so we have here invisible 1 here. So the square of minus 1 will give us positive 1. Then the square root of 2 will give us 2. So we're going to have this to be 2 times. Then the square of this root minus 1 will take care of this. In other words, this will move with this, go with this. And so we are left with minus 1, the close bracket, or to this power here. Okay, minus 4 equal to 0. So from here, 2 multiplied by minus 1 will give us minus 2 or squared minus 4 equal to 0. Of course, minus 2 squared will give us positive 4 minus 4 equal to 0. And here we're going to have 0 because 4 minus 4 will give us 0 equal to 0. So you now discover that the first positive real number satisfies the equation, and also the negative imaginary number also satisfies our equation, which is your x to the power of 4 minus 4 equal to 0. This is an indication too that the rest values of our answers will also satisfy the equation. Okay, all right. If you have a better way of solving this challenge, also drop it in the comment section so that we can equally learn from you, because we are here to strike a win-win situation, a win-win balance, a symbiotic relationship. Okay, remember, Jakes loves you so much, and all of us at Online Maths TV love you so much. Thanks for always be there. Bye for now.